This is Ritesh Srinivasan and welcome to my channel. In this video, let's look at what is zero-shot text classification. Let us look at what is textual entailment task in NLP. We'll also see a Hugging Face zero-shot classification demo, right? And we'll see how that model works. Let's get started. So what is zero-shot learning? Traditionally, zero-shot learning, most often it is referred to as fairly specific type of task, which is to learn a classifier on one set of labels and then evaluate on a different set of labels than the classifier that the classifier has never seen before. So the idea is you will train a classifier on a set of labels on a data set. Now you are going to give to this model a new data set along with new labels, and it should still be able to do classification. Okay. For example, it could be a text classification, right? Where we have trained sentiment analysis on certain text, right? And now you are going to give some new text with some different labels, and the model should still be able to recognize those labels and do the classification. Now let's directly go to the demo using Hugging Face transformers, and then we'll come back to how zero-shot classification is implemented in Hugging Face transformers and what is the importance of textual entailment task in this. Okay, so for this I am using this collab notebook. So here what I'm doing is I'm installing the transformers. Okay, so this is adapted from a demo collab notebook demo given by Hugging Face transformers. So what I do over here is that we have to import the pipeline from transformers. We create a classifier object, and to the pipeline we pass the parameter as zero-shot classification. Okay, so this will download a particular model. So here they use this BART large MNLI model for this zero-shot classification. Okay, so then what we do is that we have a sentence over here. Okay, who are you voting for in 2020? And these are the candidate labels: politics, public health, economics. So this is straightforward, right? This text actually belongs to politics. So when you run the classifier, okay, this classifier has not been trained on these particular labels. Okay, that is why it's known as zero-shot classification. Okay, so it gives the highest probability over here for politics. Okay, so it has basically classified this particular sentence as belonging to the label politics. Okay, it is as simple as these 3 lines. Okay, so let us try another example where I have created a kind of a sentiment classification over here. Sentiment classifier, zero-shot sentiment classifier. Right. So here the sequence is Hugging Face is doing a great service to the NLP community, and the candidate labels are positive, negative, neutral. It is the same classifier. The candidate labels have changed, the sequence has changed. Okay, and let us see how it classifies. So here it classifies as this sequence belonging to the label positive, which is obviously what is expected over here, right? Because the text is positive sentiment. Okay, but you see the candidate labels have been changed over here. So the original model was trained on something else, and now you are changing the labels and it is still able to identify or classify text. So this is what is zero-shot text classification. Okay, now let's look at another example. I wanted to explore a little bit more. So here I have these following sentences. Okay, the first one is Hugging Face is doing a great service to the NLP community. Masala dosa is very tasty. Tesla is awesome. Of late Android phones are boring. So 4 different topics, right? 4 different classes. So I want this to be classified as data science, masala dosa as food, Tesla as automobile, and this sentence as smartphones. So these are my new labels and this is my new text. Okay, let's see what results come out when I send these sequences to the classifier. Okay, so here if you see for the first sentence, Hugging Face is doing a great service to the NLP community, it kind of misclassifies it to automobile. The highest probability you get is for automobile class. Okay, but then the next sentence, which is masala dosa is very tasty, it actually classifies it as belonging to food, right? The highest probability here is to the label food, right? Then you have Tesla is awesome, so it kind of says that it belongs to automobile. All right, and then here you have of late Android phones are boring, So the highest probability here is to smartphones. So it does this zero shot classification quite well. You might have some errors in some places which needs to be looked into. For example, in this case, it did not come under data science, but it came under automobile. The classification was automobile. Okay. So this is how you do zero shot classification using Hugging Face transformers, and they have their zero shot classification pipeline. Okay. So now how does this work? Okay. So there is this nice blog from Joe Davidson in Hugging Face where he explains this zero shot classification. And in that particular blog, if you go to this section where it talks about classification as natural language inference, so the idea over here is that in natural language inference, it considers two sentences as a premise and a hypothesis. For example, here you have a premise, right? A man inspects the uniform of a figure in some Southeast Asian country. The hypothesis: the man is sleeping. Now, what is the relation over here? This text doesn't entail this particular premise. It's a contradiction. All right. Similarly, an older and younger man smiling. So this is a neutral label because the other sentence is two men are smiling and laughing at the cats playing on the floor. Okay. Whereas here, a soccer game with multiple males playing and some men are playing a sport. So this some men are playing a sport is kind of a inference from this text. That is why this is an entailment. Okay. Now let's go a little bit into what is entailment task and then come back to this particular text over here. Okay. So for the motivation for textual entailment is that text applications require semantic inference. Okay. A common framework for applied semantic is needed, but it is still missing. Textual entailment may provide such a framework. Okay. So for example, here you have text: the Dow Jones Industrial Average closed up, Dow Jones ends up, Dow climbs up 255, Dow gains 255 points. Okay. Stock market hits a record high. So you have these different texts which are trying to say the same meaning. Okay. The meaning over here is that the stock market is going up. Right. So you have paraphrasing where you have two pieces of text which are more or less equal. It conveys the same meaning, right? That is paraphrasing. But in entailment, it generally means that it is a task of deciding, given two text fragments, whether the meaning of one text is entailed from another text. Okay. So for example, if you have these different texts as text 1, Dow ends up, Dow climbs up 25, and the text 2 is stock market is going up. So the stock market is going up can be inferred from this text. Okay, that is the task of textual entailment. For example, in question answering, you have this: who killed Kennedy? Okay, the expected answer is X killed Kennedy. So the assassination of Kennedy by Oswald killed Kennedy. So this is the text. This is the hypothesized answer. So this hypothesized answer entails, basically this text entails this hypothesized answer. Okay, so this is the textual entailment task in NLP. So any problem, be it information extraction, okay, for example, like X kill Y, or X acquire Y, this is a kind of an entailment, right? So you can express information extraction as an entailment problem. Multi-document summary, okay, a redundant sentence or expression to be omitted from the summary should be entailed from other expressions in the summary. Okay, so textual entailment can be used for multi-document summary. It can be used for information retrieval, right, for machine translation. Okay, to evaluate a correct translation should be semantically equivalent to the gold standard translation, and thus both translations have to entail each other. So you can use textual entailment for these different applications. Okay, so here there are more examples of what is this textual entailment, and it is also directional. Okay, a text T entails a hypothesis H if H is true in every circumstances in which T is true. Okay. So you have expression 1, expression 2 means expression 2 should be true in every sense. Okay. Every circumstances possible world in which this is true. That is the idea over here. Okay. And it is directional, and more details are given in this particular PDF. I will share this PDF in the description of the video. Okay. I'll share a link to this PDF in the description of the video. Now let's go back to, now we have understood what is textual entailment, right? So now let's go back to how textual entailment is used for zero shot classification. Okay, so what they do over here is that they do a nice trick whereby they can model, okay, a pre-trained sentence pair classifier, okay, as an out-of-box zero-shot classifier. So what they do is that the idea is to take the sequence we are interested in, okay, as the premise, turn each candidate label into hypothesis. Okay, now if your NLI model or the transformer model predicts the premise, entails the hypothesis, we take the label to be true. So if you go back to this code, the idea is that if you are to look at this sentence, okay, you will construct sequences like Hugging Face is doing a great service to the NLP community, data science. Okay, another sequence is Hugging Face is doing a great service to the NLP community, food. Hugging Face is doing a great service to the NLP community, automobile. Hugging Face is doing a great service to the NLP community, smartphones. So for this particular sentence, you have 4 sequence pairs where this is the premise, this is the hypothesis. Okay, now you will feed that into a transformer. Okay, what this transformer, you will feed this into a transformer, and the transformer will have a head, okay, a classification head, which will predict one of the following, whether it's a contradiction, neutral, or entailment. Okay, so this transformer has been trained like this. This transformer's head has been trained like this on some other sequence pairs. Okay, so now this new sentence will be sent like this to this particular transformer model. Okay, and if it predicts it as entailment, that means that the most possible label is that particular label. For example, in this case, it has actually predicted entailment for automobile class. Ideally, it should have been data science. Okay, but it has been predicted for automobile. Okay, so this is how zero-shot classification works. Okay, so if you take this second example of masala dosa is very tasty, what it does is that it will create sequence pairs with each of the class, food, data science, automobile, smartphones, and then it will send it to the transformer, and it has given this particular probability of 0.99 for entailment for this label food. Okay, that is how it is shown over here. Okay, that is how the zero-shot classification happens over here. So the idea over here is that you use a transformer architecture like BERT, okay, whereby you can convert this as a natural language inference task using this premise and hypothesis, where your label becomes the hypothesis and premise becomes your input sequence, and you will compute the basically classification probabilities for each of these 3 classes, contradiction, neutral, or entailment, for all the labels, and then you will pick the one which is entailment, which shows as entailment as the probability, and whichever is the highest probability, that is what is actually given back as the label. Okay, so that is what is explained over here. There are some finer details of this also, which is available in another link which I will share with in the description of the video, where they also do multi-class, multi-label problem also. Okay, for example, you can have a text which can belong to automobiles, smartphones, data science, and food at this and not food. Okay, possibly it could be something like a text which talks about self-driving cars, which is connected with smartphones. Okay, and makes use of machine learning algorithms. So in that text, you can have all 3 classes coming up, right? So that's a multi-label problem. So even multi-label problem is it is possible to classify using this classifier pipeline. Okay, I hope you have understood what is zero-shot classification, what is the textual entailment task, how you can actually do zero-shot classification with the Hugging Face transformers. If you like the video, please like, share, subscribe to the channel. See you in another video. Happy learning.